Welcome for the second and last panel of today, and thank you for staying up to now to look at the panel. We have still some session after the panel, but here we have the opportunity to have a lot of key leaders in the industry along with Nick to discuss about the chiplet. You heard about chiplet. It's the new shift from modular system where you can combine different technology, different for the economics, but it creates a lot of complexity to come, a lot of challenge in verification, a lot of standard to come, and this is the discussion that the panel have today about the Great Verification Chiplet challenge. So I start to introduce you Nick Flaherty. So Nick is editor-in-chief EU Europe. Nick has been writing about semiconductor in Europe for over 30 years with electronics time and electronic engineering, and now with EU Europe as editor-in-chief and automotive editor. He tracks development in semiconductor technology from process technology through design tools to test and verification, and across all sectors from AI for data center to autonomous vehicle. A lot of things that you cover, Nick. He has a physics graduate of the University of York in the UK. I give the stage to you, Nick, to start discussion.
Thank you very much. My next step is to introduce our esteemed panel, which is fantastic to have them along this afternoon. Dave Kelf, who is there, if you wave, is CEO of Great Verification Systems, and he was previously a Chief Marketing Officer responsible for all aspects of the marketing activities, strategic programs, and channel management. Earlier, he served as Vice President for Worldwide Marketing at OneSpin and holds a Bachelor of Science degree in Electronic Computer Systems from the University of Salford, fantastic place, and a Master of Science in Microelectronics from Brunel and an MBA from Boston University. So, welcome, David. On the end, we have Axel Janker, SoC R&D Manager at Nokia. He joined Nokia in 2020 to help with the turnaround of the Nokia SoC business. So, very good challenge there. And is now responsible for the L1 ASIC developing SoCs for base stations for 5G and beyond. Previously, he worked in R&D in companies such as Infineon and Intel, and in design services companies like Wipro and Sondra. So, welcome to Axel. Bodo Hoppe, I'm sorry, Hoppe, yes. He's a distinguished engineer in IBM Research and Development, responsible for ensuring the design quality for performance and functionality of the IBM Z system microprocessor and system ASICs. As a thought leader in verification methodology, he's introduced multiple innovations to verification approaches and is leading the transformation, enabling the user experience, driving the hardware development from design thinking and to feature-based development. Welcome, Bodo. Thank you very much indeed. And our fourth panel member, Moshe Veldberg, CEO of Veriest, who's been all over the show over the last 2 days. A seasoned executive with more than 2 decades of experience in the semiconductor and design automation sector. He holds a degree in electrical engineering from Technion Israel Institute of Technology and an MSc in electronics and an MBA from Tel Aviv University. His career involves roles at Cadence as General Manager Israel and Head of Professional Services, and as General Manager for Israel and VP of Business Development at Presto Engineering. He's also a Managing Partner for Israel for Silicon Catalyst, which is an incubator dedicated to supporting early-stage semiconductor startups. So, thank you very much indeed, Moshe. Delighted to have you along. If you're going to give our panel So, we had a series of challenge statements for actually what it is that we're talking about, the Great Verification Chiplet Challenge. why are chiplet designs not going as we thought they would go? There was the opportunity to tackle the complexity, ever-increasing complexity of chips, break them down and create the Lego blocks for building complex systems. It's not working out that way, and we've got a series of 4 statements from the panelists. We'll ask some questions, start some discussions, and then we'll open it up to the floor. So, David, if we're going to get with you first, is that all right?
Sure, yeah. Well, so firstly, I mean, obviously chiplets is a huge opportunity, right, for creating a market where a lot of individual companies can all contribute to one die, but they can produce their own, contribute to one package, producing their own dies, and that leads to lots of opportunity. I think the devil's always in the details. The area where we're focused is the verification of these chiplets together. And if we think about regular SoC verification, where people will just put in real workloads and test out a full SoC and make sure the buses, the coherency, and all those aspects are correct and work well. With chiplets, we now have a situation where you've got to interface multiple different dies from different companies. And so those interfaces, bonding from one die to another, adds a whole bunch of latency issues, performance issues, power issues, and coherency issues as well. So we end up with a very complex interconnect system. So just to the point where the SoC interconnect was being solved by these really nice NOCs. Now we have a situation where the NOCs are broken right across this chiplet system, and we've got to go back and figure out how we interface that. So we see standards like UCIe coming out to handle a lot of this, and that certainly helps a great deal, and I think will solve a lot of these problems. But the verification of, say, the coherency data around that set of chiplets through the NOCs on the individual chiplets and then through the UCIe interfaces becomes a huge challenge. Power domain control across the whole thing becomes a huge challenge, and so on. And I think that's really now where the state of the art is in terms of the verification of these devices, and probably the biggest thing that I think is holding them up, apart from maybe some of the physical aspects of that.
Lovely, thank you, David. Excellent.
Yeah, okay. So maybe just as an explanation, so on our side, I'm more coming from a chiplet design where basically all the dies of the chiplet, can I use it here? Yeah, this should also work. So where all the dies in the chiplet are basically coming from the same company, so either from us or from our supplier. So basically we're not having necessarily this problem of combining dies from all different companies, and I think this is even still a longer way. And when I'm looking at the challenges we are having today, I would say yes, there are some challenges with the interfaces between the dies. You might have there are some standards, but when I'm really looking at the verification planning and we are just doing it for a very complex device, in the end it's really just the complexity, which is a challenge. For me, just from a verification plan, it really doesn't make a huge difference compared to an initial design planning we had 2 years ago where it was just a complex SoC. There's some more interfaces in between. I see this kind of the challenge with all, latency, etc. But we also had it beforehand. So I don't see there's a big point. For me, when you're really asking me what are my biggest concerns about chiplets as of today, honestly, it's not verification, it's more really about qualification, reliability, all these physical aspects. This is one of the biggest challenges from my perspective. So that's my view as of today in short.
Lovely, thank you very much. Gordon?
Yeah, so from my perspective, I'm a pure verification engineer, so I'm going to talk about the verification challenge only. What he's actually talking about scares me because I don't know enough about it, but I can see that the reliability, the different technologies and how they fit together can present a challenge. So looking at this from a verification challenge, I'm coming from a mainframe where you have a lot of chips that have these physical interconnects, high-speed interconnects with 2.5 gigahertz and whatsoever. We can model these delays. We can do all this today, right? So I think putting more chips together adds the complexity, yes, but it also offers a lot of opportunities. If you think of UCIe coming. It's really a standard coming pretty early before many people are doing it. So, and I think that offers a huge opportunity for, on the one hand, having qualified VIP that helps us adopting it. I think it even helps if people have already dies there that they want to sell, that there's prototypes there. I think there can be FPGAs providing IP that can help to verify these interconnects. But apart from it, it really boils down to something that we do on SoCs too, right? We don't re-verify all the IP that we're getting. I mean, we're doing there a lot of integration testing, maybe software performance. So for me also, it's not different than today's verification problem, other than it's a bigger system.
Thank you, Bobby. Mark?
So, is it working? You have to push it.
Red is it?
Red. Okay, red is good.
It's a bit confusing, this one.
Okay, now we know it. So to get back to your original question, Nick, you said that chiplets are not working. So I think that before, as good engineers, before we address a problem, solve a problem, we need to define the problem. I think it's like this joke about the different, the blind trying to understand what's an elephant. So chiplets is an elephant. It's an elephant in the room or outside the room. And there are different, not all chiplets are equal. So I think Axel touched on that. Today, chiplets are being done and successfully within big companies. So Intel, NVIDIA, AMD, they are doing chiplets where they have one or multiple processor chiplets and memories and etc. Everything packaged together. So this is there, and then I agree that's a scale, a capacity, a volume kind of problem. Moving on to the vision where there is a marketplace that each one of you sitting here in the room can bring his chiplet, and we have a plug fest that everything connect to each other through UCIe. That's a completely different ballgame, and each one of these different ballgames will have different solutions, different challenges and different solutions.
Okay, well, and I think if we delve into some of that, at the front end for this, then, do we need, if we're going to pull together chiplets from different suppliers, do those suppliers need to provide the models and the verification data and all those things that you would need to put it all together? Is that necessary? Is that possible? Or do we treat it like a circuit board and go, well, we'll put some chips there? David, we'll go in the same order. It'll make your life easier.
Okay, yeah. So, so I think. Sorry, can you repeat that last part of the question?
Do we need the models? If you're supplying a chiplet,
right.
do you need to supply all the models?
Yeah.
All the virtual models, all the verification data, and then if you're putting it together, how do you know the quality of all of that?
Well, I think what Michelle said is correct, right? That today we are seeing chiplets being, or chiplet-based designs being built in the larger companies. You mentioned some of them there. And we do see that today, and we're all working on them. That's great. So you're right, the holy grail is this idea of the marketplace of chiplets where they're being combined into one package, right? And what I think, what we're going to see, of course, is some kind of general contractor, if you like, the guy that's going to own this ultimate design, pulling in the IP in terms of chiplets, like as you say today, they pull in IP and put them on the SoC. So that general contractor is going to need a certain amount of requirements and what have you. There's actually an interesting article. I think there's a group, CEX, I think, something like that. And they are trying to define a set of models for different aspects of chiplets, which will be required to sort of be produced with the actual designs themselves. To allow the general contractor to sort of fit this all together. And they have everything from, all the verification items, right, the system VIP maybe for UCIe interface, that kind of thing, but they also have thermal models, a lot of models related to how the packaging needs to work around the chiplets and so on and so on. They actually define like 12 models that would be required. So I think you're right. I think, to create this general marketplace, which is a real challenge for sure, all this different data is going to be provided. It's all going to have to be machine readable, so that different tools can understand it and use it and pull it together. So all these sort of dynamics of these chiplets coming from different places with maybe different power constraint requirements, different thermal problems, different this, different that, can all be sort of gathered together and placed into this sort of single package, and actually the whole thing worked from all these different sort of 12 aspects that this group came up with. So yes.
Does that help you, Axel, or is that not something you're worried about? Because you have complete control over all your your chiplets.
Yeah, I think, okay, first of all, you know, even when you're thinking today, because just out of the complexity, for sure, you need models, you know, from the other chiplets, for example, you're not doing yourself, you need models on different abstraction levels, because in order even to challenge all these, you know, the verification complexity, you need some, I don't know, maybe some virtual models of weird dice. You also need some models, ideally, which are on really timing, cycle accuracy. Maybe even it would be great to get even some hardware. You know, like for in our case, we're typically having an L1 part together with a data processing unit, which mainly consists of some CPUs and memory controller, etc. Would be great just to have it even as a hardware version. So this is one challenge where you really need this kind of models, and you need some standards, and there for sure sometimes it's quite challenging because maybe the supplier you're working with is unfortunately only supporting this specific version of a specific EDA tool which you don't have, or which is only running, which is an actual problem we are having, which is only running on an older Linux version you are having on your site. So quite interesting. So this is definitely one of the challenges. And these are just coming out of complexity, where I just was wondering about this common marketplace for chiplets. This for me sounds a little bit like this kind of dream 20 years ago about building IPs as a Lego system, like a Lego system, which, at least when I'm not completely mistaken, never really happened. I also have some doubts about this, that there will be suddenly, you know, you're building a chiplet with 5 chiplets from 5 different companies. I don't see this happening, honestly. I don't believe in this. Yeah. But that's a different topic.
Yeah. Actually, can I just quickly respond to that?
Sure.
So you're definitely right that it's a hugely complex thing, and maybe just too complex. Yeah. But you know, there's no one from Intel on the panel. But I think if Intel, with the IFS group and what they're trying to do, and I don't want to put words into Intel's mouth, but I think they're trying to head in this direction with IFS, right? I think they're trying to create a world where they can be manufacturing system-level chips, where they're bringing chiplets from other places and other customers and trying to do that.
Sure.
Whether it'll be successful, that's a great question.
That's exactly.
I don't know.
I know. Yes.
But people are trying to go in this direction.
And we don't have TSMC on here as well. And
No.
they want to do it exactly.
That's true. Yes.
And if so I agree. There are multiple people. You know, there is a smaller company in the U.S. called 086 trying to do this in a smaller scale. There are quite a few people trying to do that. So, you know, Axel, you and I said we're going to disagree on something. One thing I think that we jumped into the problems and the challenges, etc. We skipped the motivation. And when we had, today the economics are such that you may need to go in the chiplet direction. And so far, we didn't solve the problems because we didn't need to solve some problems, and now we have to. Mm-hmm. So the market dynamics might be different than they were 20 years ago or 10 years ago.
Mm-hmm. Well, are you as a single house for that one?
Well, I think I understand the dream, and this may be coming. I mean, if I look at this, and I think your question was about models and what models are providing, and I think we can really separate the different things from each other, right? One is the logic functionality. I mean, right now, if you look at like UCIe and stuff like that, I mean, these are like streaming interfaces going through PCIe, going through AXI, and even CXL, right? I mean, these are standard interfaces, so you provide IP. So typically, I mean, what we do, I mean, we just kick out these physical interfaces when we do functional verification. Mm-hmm. So I think that can be just separated. I mean, the one part is, our PHYs talking to each other, or the logic layer talking to each other, right? That's one part where I think it's really beneficial to have a good standard to ensure this. But then there's the logic layer. I mean, just as you would include your IP in your simulation model. I mean, you would wish to have a model, depending on how the interaction is. But I mean, I don't really see that you're going to work with somebody very close together on a functionality where, you know, 4 dies together provide a complete new functionality and are nothing but each other. It will be really building blocks which have very dedicated interactions, which I think can be verified with behaviorals and drivers as well.
But you are going to have your host processor and perhaps a different range of AI accelerators as the chiplets. It seems to me every AI startup is wanting to sell its accelerator as a chiplet to whoever will buy it alongside that. What do you guys want to see from those startups? Because they're burning enough cash on actually just designing the things, let alone the tools and the software and all the things around it. But we've spent 30 years saying, ship things with the things we need to verify it, we need to test it. Is that going to bring it crashing down, or is it just going to mean it's a non-starter? Anybody want to take that one?
So, you know, part of the solution is similar to IP. So IP, you have encrypted RTL, you have open RTL. Maybe today, with the complexity, with the size, you can have hosted RTL in the cloud that you can access without holding it. Again, it's something that you don't see yet, but maybe will go there. Okay? But again, if you're a startup and you want to sell and you trust more or less the guy you're selling to, maybe you ship RTL, but that's not different than IP. Okay? That's one answer. Answer number 2, the Bodo touched on, you know, I think both Axel and Bodo, is emulation. You know, if you can ship the actual part, and I dealt with emulation many years ago. One of the problems we had is that sometimes we wanted to use the actual silicon for an ARM processor, and we couldn't find the actual representation of the real silicon that's going to be in the chip. And today, if that's the chiplet, if the RISC-V is the chiplet, then you have the actual representation of it. So you need to connect through a speed bridge into your emulation, and you solve the problem. And I think a third level is virtual prototyping. Okay, but maybe I'll stop here.
Well,
Yeah. So you know, there's one aspect I think that we need to sort of touch on here, and that is system verification and what is that really becoming, right? So in the past, when you're stitching together blocks of IP and you put a processor on there, you know, you could verify the IP, make sure it's connected, and that'll be it, right? And be pretty sure things are working correctly. Then we moved to a world where system verification, you know, people would start to run real workloads through it. They'll boot the OS, they would do a few things like that, run the drivers, and you know, we're pretty sure that the thing was working correctly, and that was great. Now we're seeing with larger SoC a world where coherency issues, power domain, safety, security, some of these kind of system issues you can't really just test at the IP level become more and more important, and they have to be checked at the SoC level. And you can run the risk of just running a real workload, you know, through it and hope that you might catch corner cases in these areas, but it's less and less likely, right? And my sense is that when you go to older chiplets, even if they're chiplets from one company, maybe producing an array of processors or something like that, you're exacerbating those systems problems, right? So UCIe and even the latest CXL has coherency protocols built in, right? So you're making sure the data is consistent right around this sort of multi-chiplet thing. That is just going to get worse and worse. And if we head to a time when we have NOTs, which are high speed on the chiplets and then slowed down between the chiplets, so we end up with hazards, read and write hazards between all these chiplets, which we've seen in a couple of customers we're working with, you know, that's when you start to sort of see all these coherency issues and other things really break down. And I think this is where, you know, the verification becomes really important, these things.
Lovely. Well, I think that's a good point to open it up to the floor. If people have questions for the panel, I think we have there's one at the back, Tran.
Yeah.
Yeah. The microphone's coming.
Yeah, I was wondering that how do you see the software side of the challenges? We were discussing the whole system verification, but now we have chiplets, and I guess one of the motivators is that you can scale the system, you can have different kind of variants, but most likely you only have like one software base, and you need to be sure that it's working with different kind of configurations.
But these are different questions, because I think first of all, when you're thinking about chiplet verification, and I think at least when we are speaking about chiplet verification, this always, at least from my perspective, or anyhow always includes software, because it's not just pure system Verilog test bench where no software is running. So software is anyhow needed. I think now there's a more interesting question, and you touched a little bit based on this. So what kind of software do I need there? And this is honestly one of the bigger challenges. Okay, do I need specific test software, which I have to write, for example, maybe coming from the R&D department, which never done software beforehand? Or do I wait for the production software, which unfortunately, as usual, will come only, maybe half a year later when you basically had your RTL freeze? This is for me, this is a challenge what you anyhow have, independent of chiplet or whatever, as long as you're having a SoC with some CPUs on it, you have this kind of challenge. And I think it's a very interesting topic, because this goes into everything like we just even touch base, like virtual prototype. Virtual prototype is in the end you need the software, but this is really one of my big problems right now. When and from whom I'm getting this software, and where are the people to write them, where it needs a specification, because typically and I think Oliver at some companies you were then waiting, you had your first virtual prototype done, and then you were waiting 18 months to really get the first software ready even for testing. Big challenge.
But that's not a technology problem.
No,
it's
exactly.
a management
Exactly.
problem.
It's a management organization topic, and it's not new for chiplets. Yeah.
Exactly. And to your question, again, I think emulation / prototyping could address that. Future prototyping, I stopped before I said virtual, but I'll stop here. And I was having a discussion with Jacob today. If some of you are not doing the virtual prototyping today because the ROI of maintaining a different model may not pay, if you are moving to a chiplet, to accomplish chiplet, I think the ROI, the needle moves in terms of the ROI. Okay, so if you need to have something much more complex, and you need to run software, the investment in a good virtual prototype, it's much better justified. Again, how you get this from the different vendors, it's a whole different question.
Yeah.
Thank you.
Yeah, I really think it depends on what's the functionality on that die that's being provided. What software do you need? I mean, are you going to write the software for the die that you're going to buy, or are you going to get software provided? I mean, that highly depends on what you're building, right? And I also think a lot of this goes back to virtual prototyping, and a lot of this goes back to managing, because I think, frankly, one of the biggest problems is that this all goes purely asynchronous, right? Developing these features together, I think, is one of the key issues. Am I expecting from another company, they announce that I'm getting that die in half a year, and do I get the software with it? And then, what do I do before? Am I getting anything before? Am I relying on it? Maybe I don't even have the chance to get anything in advance. So I think that really depends on the timing, how these fit together. I mean, if I just go out there and follow the dream that you have, that I'm just gonna say I'll take 5 dies and put together a module and put some great new project together, until I got that working, if all of these dies are available, I'm not sure whether the project is at the right time on the market with the software. So it's probably going to become a coordination problem. What will be available at what point in time? Much more than anything else.
Good stuff. Any other questions? No. We'll keep trying running around.
I have a question to panel. Basically, with the heterogeneous code coming into picture for SoC, where do you see C++ models getting important into making couple verification?
So if I understood correctly, the question, the C++ model, so I think it's,
Heterogeneous
right?
modeling, basically, we are now the industry is moving from ARM to this 5 cores, and of course, we cannot change all the ARM cores. We have to be some part from this 5 and other cores. So how do we tackle the heterogeneous concurrency of these models?
Yeah. Well, I'm not sure about that. Well, firstly, so I think C++ model gels, for the reason Bodhi just said, right, going to be important. You get a sense that virtual prototyping, as you said as well, Moshe, right, is going to become really critical as we sort of see all these dies coming in, which are kind of out of sync maybe, and so you need maybe a virtual prototype to get things moving. So you can maybe write some software in advance for some of the chiplets, while others are more at the RTL level. So I think C++ models are probably going to become more important. For coherency, a lot of C++ models are not synchronous, right? They're not at the cycle level, they're at the transaction level. And you can do coherency testing at the transaction level, but honestly, to really understand if you've got coherency problems, you need to be doing a lot at the cycle level. So I'm not sure a lot of C++ models can help with that, if that was the question.
Because basically what you can do is you can add a system C wrapper and then
Exactly.
Yeah. Oh, yes, sure, go ahead.
This is, in the end, it's about, you basically you need this, and I think this is when you're talking about complex systems anyhow, you need different abstraction levels, on the one side you have a loud, untimed or very, hardly timed models, which basically you can test the functionality, but at some point in time, for example, when it's about coherency, when it's about, also in our case, about specific timing problems, this doesn't work. So just a transaction, information exchange between different modules is not good enough. So you need to get a better abstraction level. It might be a system C wrapper. It might be then even going to other methods. But but I think the challenge is in the end find the right abstraction level for your problem. Just good enough, because we cannot afford to go always, obviously not to gate level, even for RTL level it doesn't work. So you must combine all these different models. Yeah. And there we are coming back to what you also addressed beforehand. How do we make sure that all these different models on different abstractions levels ideally are also working together? Because it might be good that, in your chiplet there might be some blocks which are on a very high abstraction levels, but you need some which are very accurate. And this is again, now coming back to my initial point, it's just a complexity problem. Nothing about but it's for sure it's a big one. I think we all agree on.
Nothing a PowerPoint presentation can solve.
No.
Yeah. And does that come down to the experience of the engineers and the designers for what level of that? Or can you ask the generative AI co-pilot to help you with that?
So basically, do you see a trend of a meta verification for the architecture validation? So do you see all panelists see a trend for the meta verification test bench for architectural test bench validation for architecture?
Well, I think that there has to be both, right? I mean, are you looking to find the last coherency problem? You need a cycle accurate model. Are you looking for something where you verify your module system architecture? I mean, you probably want to do virtual prototyping.
Thank you.
And I'll answer the question. Manfred Tanner from NXT. I have a question specifically in the direction towards visual prototyping on the interfaces. Do you see efforts for the interfaces on the chiplets, that exactly the interfaces, if it's cache coherent interfaces across chips, being standardized for exactly to have ensuring interoperability and also lowering the cost of ownership within the industry, so that we can connect models from vendor A to vendor B, from verification vendor A to B, and would Accelera being a place where that kind of a standardization for chiplet interfaces be a good place and become part of the, for example, the System C or the verification standards? Where do you see those efforts? Go.
I want to answer a question you didn't ask, so let the other guys answer your question you did ask.
Okay, I would love to see this kind of standardization, but honestly I'm a little bit skeptical as of today. So especially, I don't see yet really there full standardization of system C models. I'm even having problems to get, even system C models which are supposed to work for the same model working together. So I cannot imagine how this should really work together when you're basically doing this with different simulators from different companies. So there might be, I would really love to see it, and I think, but this is not only on virtual prototyping, but also on functional verification in general, because honestly, this simply doesn't work as of today. Because there's no compatibility between different systems. I'm always running into problems when I'm using VIP from this one and model from another company and trying to run it on a different simulator. And the same I'm seeing today with virtual prototypes. So I think probably we would need this, but I don't know, at least I have not yet seen this. Or maybe you disagree, but...
No, I don't, I agree. There is a need for the standards at the virtual prototyping level. I think much like what we've been trying to do in the Accelerator at sort of the RTL level, right? It's almost hard to envisage exactly what the standards will be like, but you can see sort of some of the problem statements. So maybe going back to your earlier point about look at the problem first and really try and define that, and what we might be able to do with some of those standards will be the way to go.
So I want to address this from a different perspective. Is that true for the ultimate vision of a marketplace that everyone can plug into everyone? Sounds like a John Lennon song. But when we start with a why, when we start motivation to doing a chiplet, sometimes, and if you're doing, let's say, a general purpose IP that needs to fit into every SoC, or if you're doing a merchant SoC or a chip that needs to apply to different use cases, everything needs to be compatible. One of the whys to do a chiplet is to just get something good enough for one specific application. And in this case, you don't need this, universal solution. You need something that works for that use case. I don't know, maybe Nokia needs a chip in their system. They don't need to plug to everything else. They need to do one specific function very well. So that's the question you didn't ask, but that's the flip side of the coin.
Thanks.
So sometimes back, the question or the panel name would have been the Great IP Verification Panel. So if you compare a long time back, what are the common things you would see today on the chiplet, and what are the things which are different to be handled with chiplets today?
So sorry, Oliver, you're saying, well, what are some of the things we see on all chiplets?
Look 20 years back, right? It would have been the Great IP Challenge.
Well, okay, yeah, I got you. So, and of course there's a lot of, as we've already said, I think, there's a lot of commonality, a lot of similarity between the old IP market, when the IP market was sort of building up and everyone was saying, yeah, we're going to be swapping all this RTL code between all these different companies, and a lot of us, stood on panels and discussions said, that's never going to work. There's a million reasons why that's never going to work, but here we are doing that today, right? The difference, I think, is the interfacing and the fact that on these huge SoCs, obviously the NOCs that run across them today are very high performance, and as we said before, once you break that up and you spread that across these multi-chiplet systems, how are you going to get the same performance out of the whole thing? And how are you going to be able to sort of deal with all those interfacing problems? But Moshe said the right thing, right? Is that what we're really trying to do here is maybe create these individual blocks. And those individual blocks can be self-contained, can have, even maybe the software that runs them, everything built in there, and be very self-contained. And maybe the interfaces between them are not so rigorous, so maybe we don't have to worry so much about some of the coherency issues and things like that. So a lot of it depends on the architectures we try and build, where we try and go with this. There was another article, I think in the E-Times, that talks about 4 use cases for chiplets. And it talked about your use case, right? Where one company just says, hey, this is an easy way to sort of basically take all my IP blocks and just put them in one die, but get higher yields.
That's exactly, that's really.
That's right, yeah. So there's that. Then there was the companies, I think Tenstorrent's trying to do this, right, where they're trying to build a big array of the same processors and then create an AI type system like that inside the chiplet, again, trying to get higher yields, which is a little different. There was one other, and then there's the one with sort of the holy grail case, shall we say, where we just have this market of these chiplets. And depending on those architectures, it's going to all be, I think, very different, the requirements.
So, before I said it's not a technology question, it's a management. Now I'm going to say it's a legal difference. I was thinking about asking people to raise their hands if you are an IP vendor, but if you integrate an IP in your chip and the chip doesn't work, the liability clause in your contract with the IP vendor doesn't buy you much. Okay, it's your problem. Now imagine you are putting together a chiplet and you have an ARM or a RISC-V chiplet inside this chiplet, the packet. A CoWoS package might cost you $1 million, okay? And then this CPU doesn't work. Whose problem it is? It's a different ballgame.
Good point.
I think one more aspect just on the IP challenge, I just want to compare to the Great IP challenge. I think one of the difference now that we have is we're in a different position where if I look at UCIe, we at least have standard streaming interfaces that we combine, right, which we didn't have before, right? There were all sorts of buses and stuff where we wanted to connect. So I think that gets us into a better position.
Yeah, maybe, and just as a last remark to this, I think there's even a benefit on this chiplet standard interfaces because the interfaces are fixed, you cannot change them anymore. And because this was one of the challenges in the old days, because there were always these requests, because for performance issues I need this little bit slightly modified interface, blah blah blah. This is simply off the table. So this is really the interface, and this is for me really to handle this growing chip complexity, you need some standard and fixed interfaces. And this is really one good thing here, is that because in the end, when you have some chiplets you're buying from someone else, you cannot change it anymore. That's good and bad, but I think it helps on this complexity perspective.
Yep.
Yeah.
Thank you.
Dan here from Huawei. To address what Bodo said in the beginning. We have these chiplets which are kind of, if they're coming from different companies, you could look at them like they are complete SoCs with the software running on them. That they complete a function and you want to build something bigger based on it. But what's your take on it? That if you look at it, that you deliver this software on top of it, it doesn't, from a software perspective, when you want to integrate something, they're not really a good representative for verification, because they will probably not be very complete from a verification point of view to see what's going on between the different chiplets, because they are mainly concerned about fulfilling the function. So this is where I would like to know if not virtualization is a good idea to develop this, just like when you develop an SoC, when you send it to the fab, you send different kind of software binaries to them and say that, please run this before you start making millions of them. So I was wondering if not virtualization could be a good way to address your fear.
So just for clarification, so when you're talking about virtualization, you're talking about virtual models or so?
No, actually the development of these software test suites that you probably need to define the scenarios that you want to test.
Mm-hmm.
Because otherwise you might end up with all these happy flow software running on the different chiplets, and you're not really verifying the integration.
I'm not sure. When I hear your question, my intuition says, this is a software integration and a software testing problem, not necessarily a hardware verification problem.
No, it's quite the opposite. It's a verification.
I think it's
Maybe I didn't understand.
I think it's going a little bit back to the topic we had beforehand on the software for the hardware. And this is again going back to the question, so what is the software you're using to run on your hardware? to test with this functionality. And this is, you know, when you're just using there some kind of production software, except anyhow having the problem that it only comes to late, but it's not, this typical product software is not done for hardware testing in mind. So to test any kind
It's
of
very different. I mean, the software to the software-driven test for hardware is very different from the software function.
Yeah.
So that's what I want to address. What your view is there on that? That should probably be a very big concern.
This is honestly, this is for me indeed, this is a bigger topic. This is exactly coming back to what kind of software I'm creating in order to run on my chiplet, which by the way would be the same again for a very complex SoC. Because in the end you have to do something similar. Maybe here on the chiplet it's even more complex because you have to think about it now. I'm getting the chiplet from supplier A, so how do I make sure that it's really running together? You know, how can I test it?
Yeah, just like Bosch said, that connects it up very well. I'm still responsible. I'm building this huge system now, and I'm still responsible. And everybody's just concerned about providing their function.
And
but that's not my concern. I want to make sure it works.
So basically, if all the chiplets work and they've been shown to work, but they don't work when you put them all together.
Exactly.
It's the worrying bit.
And not from a hardware integration point of view.
No, when you put them all together, you can't actually use it.
Yeah.
But that's a good thing. Thanks for making me understand the question. So I think that's actually a huge problem when you don't, there's no standard interfaces how I would integrate software in my test suite to test the chip, whether it's an exerciser or anything, right? There's no standards for these kind of things, and that is probably a big topic.
Yeah, that's true. I mean, so something we do, right, is we do produce these software-based test benches, mainly for the design of the chip, but quite often, sometimes, they get used sort of for built-in self-test when the actual chip is in the field and actually running. We've seen this happen 2 or 3 times, and you know, so then you've got to stop talking about software and start looking at the whole software stack and see where these different things fit in the stack and what they're going to run and how it's going to work, and the architecture that you're looking at is going to make that highly variable, right? So if you have a set of chiplets and they're SoCs and they've got software running inside, like some firmware, making something happen in there, compared to the control software that's sitting on an application processor, maybe making the whole thing exercise and the whole thing run together. You've got to consider all those things differently. And I agree with you that higher level software, definitely some kind of virtual environment for that would make a lot of sense, right? Again, I'm not sure I asked the question, or understand the question properly either, but is that kind of what you're asking?
I think you're spot on. I mean, when I was involved in this verification part, it was like 20 years ago, then we used RTL simulators to develop these test suites that were necessary to not make these huge mistakes.
Yeah.
But now with virtualization, I think you have a golden opportunity to develop really good test suites in parallel.
Yeah.
Because I think none of us want to end up in some waterfall process here either. That will cost money as well.
Mm-hmm.
Just a side comment here. I think you said that you ship software to the fab to test the chips. That's not something I've seen done. Okay, there is there is a debate about whether you use, let's say, ATPG tests or functional tests, but not software tests usually. That's something you do, let's say, on your bench usually. But that's beside the point. Or unless you have a different experience.
I was responsible for the DSP subsystem.
Okay.
To make sure that it actually doesn't fail in the aspects of integrity. You need to send something that they run before they actually start making millions of them.
Okay. Well, we're coming up on the hour, so if we have one last question, if anybody has a burning question to ask. Otherwise, I think we can get the panel to sum up, because I think we've identified quite a few more challenges than we thought they were there already. So, is this realistic? We thought the IP marketplace was not going to work. Are we going to come back and the words will come back to bite us going forwards, or is this going to die before it gets started?
Well, no, so I'm sure it's going to happen. the opportunity is too great, right? And there's too many sort of too many sort of great economies of scale and everything else that can be achieved with chiplets that just can't be elsewhere. So sure, it's going to happen. But I tell you, this is an interesting discussion, and thinking about how the software implications, the test implications, all these different things. I think a lot of companies are struggling with this right now and trying to figure this out. And I think as companies, like Nokia, build internal chiplet systems, should we call them, and get that figured out and everything that has to happen there, that's a good start. And then it will take like an IFS or TSMC or someone like that to really create this sort of marketplace of chiplets, and that might take a bit longer, to say the least.
Yeah, I think for this marketplace of chiplets, for me it's still, we just touch base now on the functional verification aspects, and I think we identified some challenges, but as I also said before, and for me even the bigger challenges, and things is even today is really about reliability, qualification, really making sure that all these physical aspects are working. In our case, even they're working for the next 10 years in all different temperatures. I'm not yet heavily convinced how this will work out, and I think this will take a long time.
Yeah.
Yeah, I agree. That would also be my biggest worry. I think everything else, I think we got a good starting point with people starting off with standards rather than doing something for 10 years and then start thinking about standards. So I think we're early in the process. We got a lot of advantages with standard streaming interfaces, even standard coherency interfaces. So there's a good opportunity, and a lot of this will really be also timing. Are these things that I can buy on this marketplace really also interesting for me to make products out of it, or do I need to collaborate and then all of a sudden I get all 5 dies back from the fab at the same time, and then placed with a different challenge, and then I wouldn't be able to do rapid prototyping, for example. Yeah.
So, as a summary, I would like to address a slightly different topic. No, but I want to put this in the European context. I don't think there are many people in. So, I organized a session about chiplet at the Design Automation Conference back in July in San Francisco. I don't think there are many people in this room that are planning chiplet anytime soon, because the European chips are smaller and not the big monsters, maybe with a few exceptions. But for Europe to play a role in the marketplace, we need to start thinking how we integrate into this ecosystem. I think that's what I want to say.
Which is the opportunity as well as the challenge.
Yeah, exactly.
Well, thank you very much. As we're coming up on the air, if I can get everybody to say a big thank you to our panel.